Java statements are executed top to bottom unless this flow is altered by the evaluation of Boolean expressions. Booleans were briefly mentioned while discussing data types, and to quickly review, variables of the Boolean data type can only store a value of true or false. In this video, we will look at one of the three different types of operators used in Java to evaluate Boolean expressions. There are three logical operators in the Java programming language. First, the not operator, which is typed a single exclamation point. The not operator returns the logical complement or the opposite. This will make perfect sense when we see it used in an example. Also, this not operator is the first unary operator we have encountered. Unary meaning it only requires one operand. All previous operators and the next two have been and will be binary operators, meaning they require two operands. So the next two operands we are going to look at are the AND operator typed ampersand ampersand and the OR operator typed using two pipes. Now let's go through some examples of these operators in order to get a better understanding of what they are used for. First, let's look at the unary operator we just learned about, the NOT operator. As mentioned earlier, this operator is used to return the logical complement or the opposite. So here once again we have a print line statement, and within the parentheses is simply 1 equals 1. If you remember, this is a Boolean expression using the equality operator to evaluate the operands for equality. So running this of course gives us true, because 1 is equal to 1. Now if we put parentheses around 1 equals 1, and put the not operator or an exclamation point in front of the inner parentheses, then run the program, you see we get false in the console. Because false is opposite of true, and since the expression 1 equals 1 returns true, the not operator gives us the opposite, or inverse, which is false. Notice if we remove the inner parentheses and the not operator and change the expression to 2 equals 1, running the program gives us false, because 2 does not equal 1. And once again, if we add the inner parentheses and the not operator once more, we get true printed to the console. That is it. The not operator simply returns the opposite of what the operand it is paired with returns itself. The next example will use the AND operator. Using the print line statement again, here we have two Boolean expressions being evaluated separately, each returning a value of either true or false. If we look at the Boolean expression to the left of the AND operator, we see 2 equals 2 is being evaluated. We know this to be true. And if we look at the Boolean expression being evaluated on the right of the AND operator, we see 1 equals 1. We also know this to be true. So we can think of the Boolean expression using the AND operator as being translated to true and true. And when we run this program, you see we get true returned to the console. But if we were to modify one of the operands on either side of the AND operator to evaluate to false, so for instance, instead of having 2 equals 2 on the left, change it to 2 equals 1, we know this will evaluate to false. So the Boolean expression using the AND operator will translate to false and true. Running this will return false, because in order to get a return value of true using the AND operator, both operands must evaluate to true. It doesn't matter if the first operand returns false or the second does. If either returns false, the Boolean expression using the AND operator will evaluate to false. Now, if we were to change the AND operator to the OR operator, once again typed pipe pipe, and run the program, you see we get true. That is because the OR operator only requires one out of the two operands to evaluate to true in order for the Boolean expression using the OR operator to evaluate to true. It doesn't matter if the right operand is true or the left operand is true. In fact, they can both evaluate to true, as you can see here. As long as one of the operands in a Boolean expression using the OR operator returns true, the expression will evaluate to true. We can see this a little differently using the reserved words true and false instead of separate additional Boolean expressions. This may allow some to get a better understanding of these operators, as using additional Boolean expressions may confuse some at this point. Let's take one more look at the AND operator using the true and false reserved words. Also, we can use true and false to take another look at the NOT operator. we see the not operator simply provides the opposite of whatever follows it.